Good afternoon, everybody. Thanks for sticking around for the presentation. I know it's tempting to take off early, especially because it's late in the day. My name is Jonathan Hutchinson, and I am here to present the right-of-way tool that we developed at AECOM to do right-of-way cost estimates for NCDOT's Feasibility Studies Unit. For those of you who don't know, the Feasibility Studies Unit is responsible for programming the STIP, the State Transportation Improvement Plan. And what they do is they perform a cost-benefit analysis on any conceptual designs that are coming in so that they can figure out which projects will get priority over others. They want to build the projects that will get the most bang for their buck. So the Feasibility Studies Unit does feasibility level right-of-way cost analysis, which means it doesn't need to be spot on. It just needs to be consistent with all of the other designs. And when I say it needs to be a good estimate, but we asked them, what do you round to? And they said 100, and we said, oh, okay. So we built the tool to round to the $100 level, and found out that they actually meant $100,000, which is just a little bit different. So the STIP, like I said, they perform a cost-benefit analysis. So these are our preliminary cost estimates. They need to have a high level of precision, and we need to be able to do them quickly because their Express Designs program has over 30 consultants who each get about 5 weeks to do a conceptual design for a project and return it to DOT so that they can do this cost-benefit analysis to put into the STIP. We knew that what we would need, AECOM is one of those consultants, and we were working with DOT on it. And we were returning to them a map of the project area and a table that had a few empty spaces at the end of it that they were going to fill in. And one day, this was in 2016, we asked, is there anything we can do to help you fill in those last 4 columns in the attribute table? They said, well, this is what we're doing. And at the time, they were doing, they had a tool that would give them some estimates where they could basically draw a line for a project or a point if it was an intersection, and it would come up with a rough estimate of what they would need to pay to acquire the right-of-way that was nearby. But some of those estimates were off by more than they were comfortable with. So they wound up reverting to doing things by hand, taking the maps and measuring things and using that to try to determine how much of these properties they were going to take. So we asked if we could assist with that, and that's when we started on the right-of-way tool project. We knew that we were going to need to return to them the cost calculations, maps, and then data to back up what we had performed. So from a geoprocessing level, a lot of the tasks are pretty basic tasks. You need to identify what the right-of-way impacts are, identify the amount of that impact on the property, and you need to quantify it in terms of a dollar amount as to how much you're going to have to pay the property owner in order to acquire that land. So that part was straightforward, but we knew there was going to be stuff that we were missing, and we contacted the AECOM program manager for right-of-way, Claire Trinnell, and asked her about some of the things, and she pointed out stuff we never would have thought of, like that you might need to compensate a business because you're taking 3 of their parking spaces, and all of a sudden, they don't meet the city's codes for having enough parking for their facility, or you're taking part of their driveway, and so now you've got to figure out a new traffic flow for people to get into that fast food restaurant's drive-through. Or somebody just spent $40,000 re-landscaping the front yard, and they want some of that money back. We knew that we were going to need to have right-of-way people who have experience with that be able to verify the data that we came up with the tool and make adjustments to it accordingly. we knew that we were going to be working within certain constraints because there are so many different consultants. Not all of them are large companies. Some of them are very small companies. Not everybody has GIS. They're mostly working in CAD files. So we knew we'd have to work with DWGs and import that CAD data into GIS, project it in order to run our tool accurately. We knew that, like I said, some of those people would have limited GIS experience. We knew some of our right-of-way people had limited GIS experience. So we needed to find a way to provide them with a map that they could easily manipulate so they could look through and see those specific areas that we were talking about being impacted. They could zoom in, zoom out, move up and down the line. And we knew we needed to be able to do this quickly. So what does the tool do? The inputs in the tool were pretty simple to identify. We know we needed a right-of-way because if we don't have a right-of-way, it's kind of hard to analyze it. And we knew we'd need to have the parcels to see what those impacts were going to be. In our talks with the Feasibility Studies Unit, we found out that one of the things they do is they differentiate between parcels in urban areas and rural areas. So we needed to find out the urban boundaries so we could determine when a parcel of a certain size had to be a total take and when you could allow or you could just purchase a portion of the land. Another thing that we found in the first demonstration we ran, we had worked up this tool and we were really proud of it. We knew this is something really good, and they gave us a project they had already run and they had the cost estimates on. So we brought it in, we ran it for them while they were sitting there and showed them the estimate that was $6 million too low because we didn't know that one sliver of the right-of-way going through a car dealership happened to hit their service facility, and it was going to have to be a total take, and you couldn't just buy that little sliver of land. So we realized that we needed to account for building footprints on it. The outputs that we would get out of the tool are a geodatabase that's got a snapshot of all the input data that provides accountability. So 5 years down the line, when somebody actually goes to build it, they can understand how we arrived at that estimate because they can see the data that we were working with. It could be that a month after we ran the report, there was a whole new subdivision that got digitized and it just wasn't in GIS at that point. So we had no way of knowing about it. It has a map of the project area and feature layers of the right-of-way, the impacts, and the impacted parcels, and KMLs of the right-of-way, the impacts, and the impacted parcels. Those KMLs are so that we can throw that into a Google map and give it to our right-of-way people. They can use that. They can zoom in and out. It's something most people know. One of the other benefits is that they can pull that into Street View and do a virtual walkthrough. So they can see if that building we're hitting is really a building or if maybe it's a shed that somebody can just move over that wouldn't necessitate purchasing the whole parcel. The process is pretty straightforward. We'll receive the design, we'll process it to run, calculate the impacts, pass it off to somebody to review, and then return it to DOT. We realized that we couldn't do all of that in one step with the tool, again, because we're working with DWG files. Those are not always consistent. Sometimes they require a little bit of processing in addition to just importing it into GIS. So having that as a separate step, we built a tool that will automatically find all of the DWGs in the files that are delivered. It gives you a series of check boxes so you can pick which portions of those you want to bring in. Focuses on the polygons and the lines because that's mostly what they'll have that will actually give you the right of way. After that, we have to add a few attributes to it so that we can identify things that impact the calculations. For example, we need to know what the level of control of access of the road is because that affects how they choose to compensate the property owners. If it's a full control of access highway and all of a sudden you're not going to be able to get into your driveway from it, that creates more of an issue for a property owner than if it's, just a little bit of a widening on the road and maybe you're only taking a few feet from the front yard. We need to know whether it's a new or existing right-of-way. If you're building a new road, that's going to involve a different level of compensation than if you're just widening an existing one because somebody maybe didn't realize or didn't know in advance that there was going to be a road going through their backyard. But if there was one there, they were kind of aware of that situation. Once we bring that in and do it, we run the right-of-way tool. It spits out a map. And the most time-consuming part of this for us is doing some cartographic refinement on it because we know we're going to be handing that map back to people who are going to look at it and need something that is available for public consumption rather than just something that you can do quickly and internally. Then, as I said, it gets reviewed. One of the other outputs is an Excel spreadsheet that our right-of-way people can use that has a column that allows them to override some of the values that the tool created. That way they can account for things like having to compensate somebody for losing parking spaces or losing landscaping or losing the signage from a business. So at this point, I am going to take a second to actually show you the tool because that's far more interesting than listening to me talk. So I've got a few projects here that we have worked on before. And as you can see in this folder, we've got a geodatabase. I skipped the step of importing the DWGs just to make this a little bit quicker. So I am going to open up the right-of-way tool and the resolution's a little bit different, so I'm going to have to move things around. Take the right-of-way here. This has been dissolved. It's been processed and everything, and drag it in. Python scripting in the tool validator updates all of that information. We have to type in a project name here, and let's see, GIS 209 demo. As I said, we throw it into a Google map, so we have space here to enter a URL for the Google map. And if I can find the button to hit go, run the tool. It goes through each of the steps. It is right now working on generating those right-of-way cost estimates. And when this finishes, it'll have, you can see it went through all the parcels. This is a small project, so that it would run fairly quickly. Right now it's calculating the rotation angles for the map so that it can zoom to the right area and adjust it so it looks like it's centered. And, okay. Now it is updating the map, putting in the project name and the project number into portions of this map template, and it has completed. So now you can see that it's created the geodatabase with all of the source data that we used. Here is the impact file. If I go to the table, you can see that it has cost estimates all the way over at the end. One of the things that really makes this possible is North Carolina, I'm sure you've heard several times today, is on the leading edge of a lot of GIS data. And we have a statewide parcel layer where all the counties can upload their parcel information. It gets put into a common schema. So if we've got projects that run across multiple counties, we don't have to worry about, well, one county calls this the total value, one county calls this the value, one county calls this the p-value or anything like that. So yeah, you can see it's come up with several different estimates for the right-of-way. Those are kind of as a guide to our right-of-way people in case they decide that what the tool identified as a total take really wasn't, or something that the tool identified as a partial take might actually be a total take. Let me open up the map. Okay. Let me open up the map and show you what it output. Another field that we add to the data when we create it is a field that allows us to have multiple sections or alternatives in each file. By doing that, it saves us some time. This was a small project. It only impacted, I think, 6 parcels. So that's pretty easy to do really quickly. But if you've got a project that stretches out over several miles and maybe has several different sections to it and several different alternatives, that could get really time consuming. So rather than have to redo all of these steps multiple times, we prefer to just do it once. And you can see it's got the project number in there, has the project name. You can see that it's zoomed to the area and it's rotated the map so that the project kind of fits in the data frame better than it would necessarily if the rotation angle were just having everything due north. There is another project I have in here that was a demo. We were talking to some other locations about doing something similar, and I moved one of those projects into North Carolina so we could run it for this demo. This one actually has multiple alternatives and multiple sections, so this will take a little bit longer to run, and I'll just come back to it in a second. So what we found is that since 2017, since May of 2017 when we began this project, we've run over 200 projects through the right-of-way tool. They're averaging about 100 parcel impacts per project, which is skewed a lot by a few projects that have several hundred parcels. I didn't check on the mean, but I know that most of the projects we work on have around 30 to 40 parcels that get impacted. The average time that it takes us to do is 11 hours per project. That's 4 hours of GIS time, and the majority of that is spent in label placement and cartographic cleanup of the final product. And then 7 hours for the right-of-way analysts to do a virtual walkthrough and make their adjustments based on their years of experience. It saved us a lot of time. Before we started doing the tool, we used the same formulas that DOT gave us for calculating these to do it in GIS, but basically manually calculate that. And it took the GIS analysts that we have 1 week to come up with the estimate for the project that we were testing. And as I said, the GIS side of this is about 4 hours, so we're saving about 36 hours of work per project. As far as DOT goes, if they send it to their right-of-way group to do an analysis, they do obviously a much more in-depth and much more precise analysis or a much more accurate analysis than what we're doing. The example I like to use is you can go buy a suit off the rack, and it's not, it'll fit okay. Or you can go to a tailor and have them make you a suit, and it's going to fit perfectly and make you look great. And what we do is kind of in the middle, where you go buy a suit off the rack and you take it to a tailor and have them, tighten it up. So it doesn't look quite as good as that handmade suit, but it'll look a lot better than just something that you got off the rack at Walmart. And so it would take their right-of-way group up to 6 months to process a right-of-way request, and we're returning these within 30 days. We really got slammed the first year that we were doing it because they said, you need to give AECOM 30 days in order to return this. And so sure enough, 30 days before the STIP deadline, we got hit with about 30 projects, and we had to turn them all around. Fortunately, we had a lot of people working on it and putting in the extra hours so we could get it all back to them by October 1st so they could program the STIP. So let's go ahead and check back in with okay, let me try this. check back in with that right-of-way that I was running, and it has succeeded. And you can see this project has 4 different sections, and section 4's got 2 alternatives, so you can open it up. Like I said, I just dragged this up to North Carolina. It was from another state, so this doesn't reflect anything that is, in the works anywhere, but it was something that has multiple levels of control of access. It has multiple sections, just so you could see, what this can do. And trying to open these, and of course, ArcMap takes its time. It's probably because it's also trying to pull in some aerial imagery for the background, because we want to make the maps look nice. People seem to like aerial imagery. So here we go. So this is a portion of it. I guess I could just preview the right-of-way itself over here to give you an idea. So, of course. So this actually, what would be better would be if I brought it into ArcMap. But let me go back down here and show you that in the geodatabase, you can see that there are right-of-way impacts for each section. And you can see the data broken down here by the parcel impact. In section 3, we have some areas that are full control of access, some areas that are partial control of access. I have no idea what's going on. Oh, well. So, well, the joys of technology. Sorry about that. Yeah, exactly. I did. I was trying to go a little bit too far on this. But if anybody has any questions, I'll be happy to answer them. No, I unfortunately, I have no or little to no control over that. But yes. The right-of-way layer, it's a closed polygon that represents ideally it represents the total right-of-way. Some of the projects that we get back from the consultants have just the new right-of-way, so it's got a gap where the existing right-of-way is. That's a little bit less than optimal because sometimes their parcel boundaries don't perfectly line up with the parcel boundaries that we're using, but it still produces essentially the same result. If if you're missing less than a square foot per parcel, then it's not going to greatly impact it. So yes. We don't identify the parcels ahead of time as being a total or partial take. The tool identifies that, and let me show you the. Let me log in first. Oh, thank you. Yeah. So I can, of course, I've got lots of stuff on here. I can show you the table that we create. One of the cells that it populates is actually an Excel formula, and one of the things that we do before we pass it off to the right-of-way people is do a text to columns calculation on it, which formats everything so that it comes in as Excel. And that allows them to enter the data into a specified column, and it'll automatically override whatever the tool had generated. It also applies the same multiples, the same multipliers to the cost that are applied when the tool runs, so that if they're just adding something to it, that also gets calculated the same way. So yes, to answer your question, yes, we can go back afterwards without having to rerun the whole tool to identify something that as a total take. And sometimes our analysts do it. It's actually been more frequent that they've gone the other way, gone from a total take to a partial take. And obviously, one of the big differences there is with a partial take, you're only calculating the land value of the area that you're taking. With a total take, you are going to take the entire value of the parcel with the multipliers that DOT applies to it. And I have some. Okay. I know I have some source data or some completed projects in here, but I'm not seeing them. So let's see. Okay. Okay. Well, anyway, any other questions? Anybody? Yes.
So, how much effort would it take for you to reorder this to comply with ArcPro?
With ArcPro? I have not looked into that yet. I'm not as experienced with ArcGIS Pro. In fact, one of my plans is to attend the session. Sorry, the question was how much effort would it take to reauthor it for ArcGIS Pro? ArcGIS Pro, from what I've seen, uses a lot of the same Python code that ArcGIS Desktop does. But the way they format their tools is slightly different. With ArcGIS Desktop, you build a tool, or you create a toolbox, and then you can import a Python script as a tool. With ArcGIS Pro, you have to author the toolbox in Python, and that allows you to then create the tools in it as subroutines. So it's slightly different. I don't think it would take a lot of effort to do. It's just something that would take a little bit of time to do. So, yeah. All right. Well, thank you very much for your time.